So last time we did 1A and B. We're going to do C right here. So C says, write but do not evaluate an expression. So this is, we don't have to worry about the final numerical answer. We just need to write an expression for this. For the volume of solid, if R is rotated around the vertical line, x equals -1. So this is same idea as A and B, but very different setup. So x equals -1 is over here, approximately. So that's my axis of rotation. So if you guys remember from last time, our first task when we're doing a volume type question is we're going to ask ourselves, we're going to try to visualize and ask ourselves one really important question. And it's not, can you perfectly visualize this or can you perfectly draw it? We know that's going to be very, very difficult from an artistic standpoint. Even if you are a good artist, it can be tough. Your main question is this: is the resulting solid, is it going to really be a solid, or is it going to have like that bowl or hole situation? Bowl or hole. And specifically, will it be a bowl or have a hole? It'll have a big hole right in the middle, right? And you can maybe see that if you try to visualize. Can you see how there's all that space in between the axis of rotation in the region? Well, that space is going to get rotated over here as well. And so then if you did try to scratch this region out over here, it would look something like that, wouldn't it? And you're going to have this big hole right in the middle. Anytime you have a hole in the middle or it's a bowl-shaped thing, what method do you have to use? That's right. So once I've established that I'm using washers, I'm going to write this: pi integral big parentheses squared minus little parentheses squared. And at least, I don't know if I'm going to mess this up from here on out, but at least I know I've got the right format. It's a washer method. I'm not going to mess that part up. Let's see if I can get the details filled in here. Next step, really important, and it really has to be now. Would you guys say that the representative washers will be dy thick or will they be dx thick? Let me rewind a little bit. What's supposed to be the relationship between the representative element and the axis of rotation? Perpendicular. Okay, so we've got this vertical axis of rotation. So if I'm going to draw in a perpendicular representative element, and I'm going to make a little rectangle over here. It looks something like this. And I can do some more if that helps. What's the thickness on each of those? dx or dy? They're dy's, yeah. So I'd say the thickness is measured by that dimension right there. And since that dimension is measured on a vertical scale, we would say that those are all dy represented rectangles. Not that different than the area, right? Like that quiz you just got back, the one that had the area in terms of y. So these are all dy thick. And what is so important about that? It means that my integral is going to be a dy integral. Everything has to be in terms of y. Okay. Next step for me typically is I'm going to write in my limits of accumulation, right? So what would you guys say is the place where I would start accumulating these representative washers? My low integral limit. Say again? 0. Yep. Okay. Start accumulating at 0. That one wasn't too hard. The other one might be tougher. Where would I stop accumulating? It's 2. So here's why. 4, of course, is an x value. 2 is a y value. And I'm accumulating from bottom to top here, not left to right. So these little representative washers are going to accumulate from the bottom of the region up to the top of the region. So I'd start at y equals 0, and I'd finish at y equals 2. So 0 to 2. Okay. I'm going to erase some of my representative rectangles here. Actually, I'm going to erase all of them. Okay, so the last thing I got to figure out are the 2 radii. So I think an illustration of this is helpful sometimes. would you guys agree with me that this blue distance, doesn't that represent the bigger radius? Okay, so this feels a little different than what we did last time. It's really not. So would you guys maybe agree that from here to here is pretty important? And then from here to here would also be potentially important. Like the green and the orange together make up the blue distance, right? Okay, so how would I get that blue distance if it's made up of green and orange? Well, how long is the green distance? Say again? And we're always, so we can do it that way, and we are going to eventually do it that way. You can just say it's 1, right? Okay. So yeah, I'm going to show you a couple ways to think about this. And I'll try to get you to a place where we'll be very consistent. So you could say that that big radius is 1. Maybe don't write this down. Maybe just watch this right now. Just watch. 1 plus, how long is the orange distance? Let me be really, I'm going to be super elementary here. And again, all I really want you to do right now is just to watch. Would it be fair to say that the orange distance is this? Isn't the definition of x basically from the y-axis over to the right or left, right? So you can say 1 plus x. Why would it be wrong for me to leave it like that? It's got to be, yeah, it's got to be in terms of y. So what could I do to replace that x with an expression that only has a y? Yeah, couldn't I use this linear equation, which is what we're talking about, solve for x? So x would be 2y. So again, before you get too quick on writing, if you wrote it like this is perfectly correct. But I'd like to present an alternative that's just as correct and very consistent. You okay with that? Check this out. In fact, why don't I do this? I'm going to move this up so you can kind of see. Here's what I would propose. This is nice and consistent and requires very little graphical engineering like we just did. If you have a displaced axis of rotation, you can always find your appropriate radius by doing axis of rotation minus the correct function. Axis of rotation minus the correct function. This will always get you the right radius. But why would this still work just like my green and orange effort? Why would this still give me the correct answer in the end? Yeah, you're about to square it. So 1 plus 2y squared is the exact same thing as negative 1 minus 2y quantity squared. And so I prefer to just do it the same way every single time, just for sake of consistency. If you want to draw out a picture like I did there with colors and distances and all that stuff marked out, that'll always work too. I'm just thinking from a time perspective that might be rough. Okay, so then let's do the other one. I've almost used up all my colors here. Would you guys say that this red distance from here over, from here over to here, or we could go from here over to here, whatever. Doesn't that red distance represent the inner radius, like the small radius of this solid? So anybody feel like they can write down what you think that inner small radius is? Perfect. There it is. Negative 1 minus y squared. So again, if you do axis of rotation minus the appropriate function, you'll always get the correct radius, which is the same thing as 1 plus y squared in this case. So either way would work. I favor this way for consistency's sake. Okay, how y'all feeling? Wouldn't it be awesome if there was like a set of 3 more questions that were kind of like this one, but different, that you could practice with? Oh, turn the page. Nice. Okay, so we got like 12 minutes here, and I think these are all right but do not evaluates again, I think. So if y'all would, do as many of these as you can. Discuss, compare, ask questions. I think you'll find the strategies and such to be very similar to what we've been doing. See if this is a good capper for you. Check your answers in a couple of minutes. Anybody want to volunteer an answer for A, which is rotating M around the y-axis? Okay, let's start here. Is it going to be a disk method or a washer method? Right, there's going to be, is it going to be a bowl or a hole? It's going to be a bowl. Yep, okay. So it'd be V equals pi integral big radius squared minus little radius squared. Oh, it's frozen. There you go. Did you guys pick dy or dx for this one? Doesn't it have to be a dy? Because we need to be perpendicular to that axis of rotation. So I'll put dy right there. Sorry. Oops, that's not going to work. There we go. Okay, and then what about your limits of accumulation? Limits of integration from 0, right? 0 to what? 0 to 2. Good, okay. So 0 to 2 is where we start accumulating and stop accumulating. Then for my radii, I think the first one would be based on the parabola. So I would go positive root y. And then the other one would be y squared. Seeing some nods. Are we doing okay? Okay. If you wanted to get tricky about this, couldn't you, I'll squeeze these in, couldn't you do this? 0 minus and 0 minus, if you wanted to be consistent with our method for all the axes of rotation. I'm not going to write that because there's just no reason to do that other than to point out it really is consistent. Okay, great. This one, I would say this one wouldn't be too hard for us to evaluate via paper and pencil, right? Because you would just get essentially y minus y to the 4th after you simplified. That wouldn't be too bad. So like thinking about our discussion earlier, would the AP test ever have us do this? Well, maybe on this one, yeah. I can see that happening. Okay, so then B, we're now taking this and revolving this around the vertical line x equals 3, which is over here. So first order of business, will this shape be a solid, or have a hole, or be a bowl? Giant hole in the middle, right? Okay. So it's definitely washer method. So I'll go volume equals pi integral big R squared minus little r squared dx or dy. Really, it's kind of the same concept as the other one, right? It's dy. And then accumulating from where to where? Still 0 to 2, yeah. Just because I displace the axis doesn't change the accumulation pattern. And then anybody want to venture a guess for the big radius? What do you think that would be? 3 minus y squared is right on the money. That's right. Axis of rotation minus the appropriate function. In this case, the appropriate function is right here in blue, expressed by x equals y squared. Okay, anybody want to venture a guess for the smaller radius? That's right. Very good. This one would be a little more laborious as far as trying to figure out what this is via paper and pencil. So maybe this would be one where it would just be a write but do not evaluate, or maybe it would be a calculator question, but I don't think we'd have you FOIL everything out and add all the like terms and then do an it'd just take forever, right? Okay. Last one, what if we took that exact same region and we revolved it around the horizontal line, y equals -1, which of course is down there. This, of course, kind of changes everything. But from a visualization perspective, what would you say? Solid, hole, bowl. Yeah, definitely got a hole in it. And if it's a bowl or has a hole, we'd go washers. So it'd be volume equals pi. Integral from 0 to what? 0 to 1 this time, that's right. dy or dx? Dx. We switched the axis of rotation, so we are on a dx. And then, let's see here, this would just be -1 minus, this is actually how I usually build these. I'll just go -1 minus in both. What would be the further away function? It's the root x function, that's right. And then, of course, that means the inner function would be x squared. Oops. There we go. And that's it. Probably a calculator question already right, but do not evaluate. Hey, one quick plug for you guys. One quick question for you for next year. Obviously, you guys are all juniors. And so from a course perspective, in case